So I'm going to talk to you a little bit about a project I'm working on called Tezos, but this is a more generic dogs than Tezos. It's not just about that. I would say in general it's about, what can you do with smart contract platform, what is it useful for, and what is specific about this platform. Of course, I work on Tezos, I'm biased, I like it more. So the title of this talk is Tezos as a platform because you can, Tezos being a public blockchain, you can think of it as two aspects. One of it is just being a cryptocurrency in the same way as that, Bitcoin or Ethereum are cryptocurrencies, and that's one aspect of it. And I think it's an important aspect of public blockchains that is often, I would say, underestimated. But the other aspect is being a smart contract platform, meaning some sort of utility where you can deploy applications and use those applications. And so it's like, if you deploy applications on Tezos, what does that actually look like? All right, so first of all, what exactly is Tezos? So it's a public ledger and a smart contract platform, and the distinction was made earlier between public, private, permissionless. It's a good distinction. So it is public, it is permissionless. It's a piece of open source code that people run on their computer, and there are people across 5 continents running Tezos nodes and getting to consensus and maintaining a safe ledger, and that ledger can represent several things. And one of the things that it can represent is smart contracts, that is digital agreements between different parties for the escrowing of digital property. I would like to argue that Tezos is first in class in terms of its technology and design. So the way that consensus is achieved is using a proof of stake consensus. So Bitcoin came out in around when Bitcoin launched in 2009. It's a proof of work cryptocurrency, so it uses a lot of miners. They're consuming a lot of energy to secure the protocol. There are other ways of securing protocols in a decentralized fashion. One of this is proof of stake, and it has the benefit of not being as costly and of having slightly different security properties. So instead of just spending a lot of money trying to essentially bribe everyone into not attacking the network, what you try to do is that you try to put funds at stake. You try to have safety bonds that get forfeits if people try to attack the ledger. So that's one of the neat aspects of proof of stake. And I would say today, almost all of the major projects coming out in terms of public blockchain are all switching to proof of stake. And Tezos was one of the first major one to launch. It's also known to be a self-amending protocol via on-chain governance, and I'll explain a little bit what I mean by that. But in 2 words, it's a way for the protocol to not become obsolete without being centrally controlled. And the third leg of Tezos is that it has the secure smart contracts. So smart contracts are, I say, very exciting, very interesting, but they're also really hard to get right, and they're very expensive to get wrong. And so we'll see what we can do about that. It's also a community of open source software developers. There are developers for Tezos on many continents all around the world in different teams, and they all collaborate to try to make Tezos a better platform. It's a project that started in 2014, but the chain itself launched in 2018, and it's currently one of the top 20 cryptocurrency. So what is this self-amendment thing? So traditionally, open blockchain networks, this Bitcoin and Ethereum and all this stuff, they evolve by forking. And it's not just open blockchain networks that evolve like this. It's pretty much all open source projects. So traditionally, you have an open source project and someone has an idea for how they're going to make it different. And so what they do is that they take your code base, they copy it somewhere else, and then they take it in a different direction. And for open source, that works beautifully because the fact that you use one version of the software on your machine doesn't mean I have to use the same version on my machine, right? We don't have to use the same version at all. If we use a code base, for example, for a word processor, you have your version, I have my version. Maybe they can have some interoperability for reading files, but they don't have to be exactly the same version. If you're trying to maintain a ledger, the problem is that as soon as you fork your code base, you're also going to fork your ledger. And ideally, while you'd be interested in forking code bases, you don't want to fork ledgers because the entire point of the exercise is to have a unique ledger. So typically when a blockchain forks, you end up with 2 versions. And since the whole point of the exercise is to have a single ledger, one is going to be a lot more relevant than the other one. Now the issue is the way that relevancy is determined. Relevancy is not determined by which one is the best or which one has the most merit. Relevancy is determined by what is called a coordination game, or what Keynes called a beauty contest. Basically, you want to be in agreement. The systems are designed so that everyone has to gather around one point. So you're going to want to look at the ledger which is canonical, that everyone looks upon. And you have to pretty much guess where everyone is going to congregate. You can imagine maybe going into a conference like today. Imagine the conference has 2 rooms and you don't know which room to go in, but you know that the talks are going to be in a room where the most people are. And so it's not that one room is better than another, it's that you really have to pick the room where everyone's going to be, and maybe it's going to be the one that's closest to the elevator or something like that, but not necessarily anything very important. And so Tezos doesn't do that. Instead, Tezos evolves through amendments. So it's a very, it's modeled after a political process where people can propose changes to the way that the ledger works. So instead of just, copying it and going their own way, you can come to the Tezos community and say, I have this change, and I propose that this change be ratified. And there's a governance process, and it's a pretty stringent and conservative process. If you want to make, changes should be treated suspiciously, and so if there's a change, you're going to have to go through several rounds of voting. It's a months-long procedure, and you have approval, supermajorities required of 80%. So you have to go through this pretty stringent process to make it happen, but it can, and it recently did. There was the First Amendment was passed for Tezos just a week ago. And so the point of doing that is not so much to prevent forks. Sometimes people look at, they look at the forks of Bitcoin, they say, oh, there's Bitcoin and Bitcoin Cash, or Ethereum and Ethereum Classic, and they say, okay, so Tezos tries to prevent fork. You can't really prevent fork because, it's an open source code base. So if someone just wants to copy your open source code base and try to run a scam with it or something like that, you can't prevent that. But what you can do is you can create legitimacy and canonicity around a branch. What you're saying essentially is there is a real process, and that process is going to drive that coordination game. The coordination game is going to say, we follow the branch that follows the process. So instead of having some sort of chaotic forking, you can have some sort of predictability in how the ledger evolves. And that's, I would say that's fairly new, because prior to that you had 2 ways of making a ledger evolve. Either one, you decided that you were never going to evolve, you're never going to change. And that's pretty much the approach taken by Bitcoin today. You're saying, okay, we came up with a set of rules, it's pretty good, let's just go with that forever. The problem is there's a ton of innovation in this space, and you're really losing out on a lot of benefits, like having smart contracts, for example, or preserving privacy-preserving transactions. You're missing out on all of this, and so that's a little too bad. The other approach is to say, we're just going to go in any possible direction, and we'll see what happens. But then you lose some of the safety, and you lose some of the predictability that makes the system interesting in the first place. And I think that this aspect of predictability and governance is particularly interesting if you're trying to build applications. Because if you're trying to build applications, you want to know how the platform is going to evolve. Is the platform going to remain relevant? Can you have some idea where it is going, and can you have some say in where it is going? So that's basically the self-amendment part of it. Let's see. Oh. All right, so briefly, because I'm mostly here to talk about the platform, but Tezos is also a cryptocurrency. I would say that pretty much all open networks are, for a simple reason. The only ways that we know of today to run a decentralized network is safely, is to incentivize people, and the only way to do that is to have some sort of native token. So that's how Bitcoin does it, that's how Ethereum does it, that's how Tezos does it. So Tezos has a cryptocurrency, and it incentivizes participation in securing the ledger with a cryptocurrency. So essentially, if you hold a cryptocurrency, you get to securize the chain. You get to secure the chain. You get to create blocks, and then you get to get rewarded if you do it correctly. And so it is designed to be a cryptocurrency, but it's also designed to be a smart contract platform. And I would say that those 2 applications complement each other fairly well, because if you are a smart, if you have a cryptocurrency, one of the main things you can do with it is actually program it. One of the nice things about cryptocurrencies is that they are a form of programmable digital money. And if you don't have smart contracts, then there's a lot less you can do with your cryptocurrency. But I will say this, I think there's too much of a tendency to look at public chains which are smart contract platforms and think that they're not necessarily cryptocurrencies. So like, oh, you're a smart contract platform, therefore you must be like an app store and it's all about applications. I don't think that's quite true. And it's a narrative that has been shifting in this space, and progressively I would say the industry is moving in this direction of recognizing that being a smart contract platform and being a cryptocurrency is really two things that are fairly tied. All right, so let's talk about the Tezos smart contracts. I touched upon that a bit earlier. Why do I think that they're interesting? So Tezos was designed from the get-go with the security of smart contracts in mind. And mind you, this is in the Tezos papers in 2014. This is before, this is 2 years before the DAO hack. This is 3 years before the parity funds freeze. This was pretty prescient. And the idea is that instead of having a smart contract language, which is going to look like an assembly language, like a very low-level virtual machine, and that's the approach taken by almost any platform today. If you're looking at Ethereum, for example, they use the Ethereum virtual machine, or the EVM, and it's just basically bytecode. It's really a compiled code. It's not human readable, that is on a blockchain, or you can look at Hyperledger, who is using like Docker instances. You don't really have a very clear and very human readable semantics for those smart contract language. And Tezos takes a bit of a contrarian view, and instead of going with a highly optimized assembly and a compiled language, what it does is that it tries to make it so that the lowest level language you can write in is actually a fairly high level language. And it has nice property. It's a typed language. It's a functional language. Now, I understand not everyone will be technical in the audience, but there's a lot of research in the literature on programming languages, and certain properties of languages have been associated with having fewer bugs because they put more constraints in when you can write. Simple things. So, for example, if you write an integer in a Tezos smart contract, that integer can go from 0 to infinity. Almost, whereas most programming languages will tell you that your integer is going to go from 0 to, for example, 2 to the 32, and then it's going to wrap around. The reason for that is that it's more efficient to build this in CPUs. But here, we're not so concerned about efficiency. We're not trying to run protein folding programs on blockchains. We're trying to run very simple business logic. And so we should optimize as much as possible for safety over efficiency. There's no point in trying to save 10% CPU power and then at the same time risk introducing a bug that is going to cost you millions of dollars because somehow your integer was a little too big and then it wrapped around. The other approach, the other benefit you have in if you design your language this way is that formal verification is going to become a lot easier. I think I have a slide after this that explains what formal verification is. Otherwise, I'll go back and I'll explain more. Which means contracts can actually be audited. If you look at a contract on the Ethereum blockchain today, what you have to do is you have to have someone tell you, this is a source code that I compiled, and you can verify that source code, but you're going to have to trust the compiler that the source code I'm showing you and what actually runs on the chain is the same thing. You don't really have that confidence. Here you can directly go on the blockchain, you can look at what the contract says, you can look at what the contract is doing. So if you need to have your contracts audited, I would say that's a particularly important aspect. You can have confidence in execution. In my experience, I talked to some custodians who are working with storing funds for their customers, and they're usually not so keen on using smart contracts for securing them for multi-sig because they can't really audit them. With some exceptions, because if you're using Bitcoin, for example, which has native support for multi-sig, or if you're using Tezos, where you can write multi-sig contracts in only a few lines of code, then you can get that confidence. And in fact, the multi-signature contract for Tezos is actually formally verified. You have a mathematical proof that it matches a specification of this contract. So given that hundreds of millions of dollars have been lost to buggy multi-sig contract, I would say that's a pretty important property to have. All right, so why formal verification? And what is it? So software is really hard. Software is something that's maybe should be written by machines. Humans are not very good at it. It's a very it's a hard task, it's a repetitive task, and so as a result, software tends to be buggy. People make mistakes, people overlook things. And the software industry has, you can imagine that a lot of the software industry is mostly about finding and removing these bugs. And so testing helps. If you write tests, you will catch some bugs. You will, if you change your code and you have your test, you'll catch them, but you're not going to capture everything. There's always going to be corner cases, and you have to write a lot of tests. If you look at a project like SQLite, for example, they have millions and millions of tests. It's been a massive effort just trying to cover all corner cases with tests. So instead of tests, what we can do is we can write specifications. Now, specifications can also be buggy. A specification is when, instead of writing your program, you just write what your program should be doing. And you still need to get that right, but it's a little easier to get a specification right than to get your program right. And even if you get your specification wrong, you can come back and fix it. And formal verification is when you have a program and a specification, and you get a mathematical proof that the program matches the specification. So for example, specification, I'm going to have five signatories, and I want 3 out of the 5 to have the ability to move those funds, and only if 3 of the 5 agrees, then that should happen. So that's a specification. The actual implementation is different. You want to show that one matches the other. So why not just do formal verification all the time? Well, historically, it's been a pretty expensive process. It takes time to formally verify software. It takes a lot of effort. It used to be that you needed to have an army of PhD students who would know all this arcane software very, very well to do it. The cost of formal verification has fallen a lot, and the practicality has raised a lot. And so there's a simple rule of thumb to know if it's interesting to use it, which is you take the value at risk and you divide it, and this is just a rule of thumb. You divide it by the number of lines of code. And if that value is high, you should probably use formal verification. Now let's look at smart contracts. Value in some smart contracts on the order of hundreds of millions of dollars. Number of lines of code on the hundreds or thousands. So it means that you literally have almost a security budget on the order of $1 million per line of code to check that if they're correct. So it is very much worthwhile to take the time to formally verify them. And having a language that makes it easier to do so is, I would say, is pretty important. And historically, there's another, there are other areas where the value at risk over the number of lines of code is very high. Medical devices, because the cost of error can be human life. Aerospace, because the cost of error can be human life plus a lot of very expensive equipment. And smart contract. I would say that smart contract probably have the highest ratio of value at risk over line of code that we've seen in any industry. So super important. All right, so Tezos as a platform. So Tezos was designed as a generic platform. It's suited for all kind of blockchain application. It doesn't, it's not like a healthcare blockchain, or it's not like a supply chain blockchain. It tries to be very generic. It tries to accommodate any application you might want to write on it. And so when I look at the type of project that people try to deploy on blockchains, the type of ideas that I hear, I would say there are 2 broad categories. One is around data notarization and traceability. I have some data, I want to know if the data is valid, I want to know where some item came from, and so that's one category. And the other one is around either payments or asset issuance. But anytime you want to represent value on a network and move value around, or represent derivatives as the value, insurance, these different aspects. And so I'm going to give you a personal take that I have on these use cases, but they're not necessarily reflective of what the platform can do. Again, this is a generic platform. All right, so the first one is a very popular one. I hear this pitched all the time. So first of all, notarizing data. ensuring traceability in supply chain, consumer goods. These are real needs. There are real people who have these real needs. I do not doubt that for a second. I also think that if you built a solution for this, a blockchain could be part of the solution that addresses this problem, along with many other components. You would need to build a lot of things to build, to solve this problem. And if you want Tezos to be that blockchain, Tezos can be that blockchain. Absolutely, you can do it. However, if you do build all of this solution, including all the components that you need, your solution can probably just work as well, without a blockchain. You probably don't need one. And oftentimes I'll hear people who they know about their use case, they know about their industry, and they'll say, okay, I'm thinking we can do this, we can do this, we can do that, and I'm nodding along, and I say, yeah, that sounds interesting. And then we put it on a blockchain, and they say, well, why? Why? It doesn't actually bring you anything. So I think this confusion comes from Bitcoin because, in Bitcoin, all the transactions can be traced. And so people imagine, oh, so blockchains are about tracing data. Well, not really. I mean, part of it is, the hashing, but most of the work in the blockchain, most of the cost that you're paying for is not so much the traceability. That's the easy part. What you're paying for is the unicity of the ledger. What you're paying for is the safety of the consensus across the world. If you're not interested in that, then you're paying for something you don't need. So that's why I think that those cases, while they may be interesting, I don't really think oftentimes that they actually benefit from use of a blockchain, because they're about information and blockchains are about value. So if you are building such a solution, I do encourage you to check if you're actually in the blockchain. I think you probably don't, but you know your business better than I do, and so if Tezos fits your need, by all means use it. Now, asset issuance contracts. This is something that I do believe in. So Tezos I think is pretty well positioned for asset issuance and contracts because, one, you have a clear governance process. And that is going to diminish the risk of contention over which can represent true title. If I have a title to a boat on a blockchain and it forks, now there are two titles. There's a title to a boat on fork A, title to a boat on fork B. Which one represents a true title? If you have a governance process, at least you have a clear answer to that. You can also easily verify the smart contracts, which gives you a high degree of confidence in what you're actually implementing, which is important because you're moving value around, you're not just recording data. All right, so I think I wanted to leave a little more time for questions, but I still have, I think, a little bit. So open to questions.
Here's some questions from Slido. So governance and accountability seems to be a huge issue in the industry. Tezos has had its fair share of disputes too. How can the industry improve?
So I think that's the same problem as people who talk about like traceability. They say like, oh, there's traceability in Bitcoin because you look at the transaction and then you can trace it. But it's the same thing we want to do. We want to trace where the lettuce came from. So I'm going to put the lettuce on the blockchain and I'm going to trace it. And it's reasoning by analogy. And the problem with reasoning by analogy is that it's a very poor way to reason. And so, Tezos has a model for upgrading itself, which has been dubbed on-chain governance. I don't think the Tezos paper actually used the word governance. And so there's a Swiss foundation that's attached to the Tezos project that has had its internal issues. And the problem is like, oh, it's governance, but Tezos is governance as well. Interesting. But that's reasoning by analogy. It has actually no bearing on what the chain does. And likewise, the fact that you have on-chain governance is not going to help you with governance of human institutions. These are pretty orthogonal stuff. They share a word, but it's not, it's kind of like this thing where everyone thinks it's like an insightful thing, but it's actually not relevant.
All right, next question. Are there too many DLT technologies and too many players? Do you foresee consolidations in the near future?
So it depends how you go. If you look at it purely as software, I want to deploy a private blockchain, I want to use my blockchain, especially if you want to track lettuce, then you're going to see, many solutions. I don't know how much consolidation you'll see. I don't know how many accounting software is there, how many plain piloting software is there, how many. That's going to depend on how basically on the cost of maintaining different versions versus the actual demand for diversity in the market for the software. So that's for a pure software thing. If you're looking at cryptocurrencies as store of value and as forms of money, then I think that you can have very, very strong consolidation because the whole point of money is being the most liquid means of exchange, and so you have very, very powerful network effects that happen in cryptocurrencies. So in that case, probably, but I don't necessarily think on a very short horizon. I think it might be a while, because right now I would say the store of value use case is pretty real in many cryptocurrencies. The means of exchange is still underdeveloped.